In a previous lesson, we studied trigonometric, reciprocal, and quotient identities. I recommend that you pause the video at this time and refamiliarize yourself with these identities before moving on. In this example, we're given that the cosecant of theta equals 3 and the secant of theta equals 3 times the square root of 2 over 4. And we're asked to find the sine of theta, cosine of theta, tangent of theta, and the secant of 90 degrees minus theta. Let's start with problem A, the sine of theta. Well, we know that in looking at the information we're given that the cosecant of theta is related to the sine of theta. So let's start there. The cosecant of theta equals 1 over the sine of theta. We know that because of our reciprocal identities. If we were to take the inverse of both sides of this equation to solve for the sine of theta, then we would get the sine of theta equals 1 over the cosecant of theta. And since we're given that the cosecant of theta equals 3 in the problem, the solution is 1/3, 1 over 3. Next, we have the cosine of theta. Again, if we look at the information we're given, we see that we're given the secant of theta equals 3 times the square root of 2 over 4. And since the cosine and the secant are related, we'll start there. So the secant of theta equals 1 over the cosine of theta due to our reciprocal identities. And again, if we take the inverse of both sides of this equation and solve for cosine of theta, we would get the cosine of theta equals 1 over the secant of theta. Since we're given the secant of theta in the problem, we can substitute that in. 1 over 3 times the square root of 2 over 4. When we divide by a fraction, we multiply by the inverse of the denominator, and we get 4 over 3 times the square root of 2. To rationalize the denominator in order to get rid of the radical, we'll multiply both the numerator and the denominator by the square root of 2. And we get the 4 times the square root of 2 over 6. The 4 and the 6 reduce down to 2 times the square root of 2 over 3. Next, we have the tangent of theta. Recall that the tangent of theta equals the sine of theta over the cosine of theta. And we've just seen in the previous two problems that the sine of theta equals 1 over the cosecant of theta, which is one of our identities, and that the cosine of theta equals 1 over the secant of theta, also another identity. Since we already know the value to these two trig functions, all we have to do is substitute in. So we have 1 over 3, because cosecant of theta equals 3, over 1 over 3 times the square root of 2 over 4, because we're given that the secant of theta equals 3 times the square root of 2 over 4. Now we just need to simplify. So we have our numerator 1/3, and we have a whole nother fraction in the denominator, so we need to simplify that first. 1 divided by 3 times the square root of 2 over 4, we can simply multiply by the inverse of the denominator to get 4 over 3 times the square root of 2. Again, we have a fraction over a fraction, so we're going to multiply by the inverse of the denominator. So the numerator 1/3 times the inverse of the denominator, 3 times the square root of 2 over 4. The 3's cancel, and we're left with the square root of 2 over 4. Finally, we have the secant of 90 degrees minus theta. Now this is a cofunction identity. So recall that the secant of 90 degrees minus theta equals the cosecant of theta. And since we're given this in the problem, the cosecant of theta equals 3. Now pause the video and go ahead and try these problems on your own. There are many ways to solve these problems, but the goal in this lesson is to use the information that we're given to try and solve these problems. So we're first asked, what is the secant of 30 degrees? Well, we're given that the cosine of 30 degrees equals a number, and we know that the cosine and secant are related, so let's start there. The secant of 30 degrees equals 1 over the cosine of 30 degrees. We know this because of our trig identities. And since the cosine of 30 degrees equals the square root of 3 over 2, we can substitute that in. Since we've got a fraction over a fraction, we're going to multiply by the inverse of the denominator. So we're going to end up with 2 over the square root of 3. Rationalize the denominator, multiplying the numerator and denominator by the square root of 3, and we have 2 times the square root of 3 over 3. Next, we're asked to find the cotangent of 30 degrees. Again, if we look at the information that we're given, we can see that the tangent of 30 degrees equals a value. The cotangent and the tangent are related, so we'll start there. The cotangent of 30 degrees is equal to 1 over the tangent of 30 degrees via one of our trig identities. Since we know that the tangent of 30 degrees equals the square root of 3 over 3, we'll substitute that in. When we divide by a fraction, we multiply by its inverse, and we'll end up with 3 over the square root of 3. Next, we'll rationalize the denominator by multiplying by the square root of 3 over the square root of 3, and we get 3 times the square root of 3 over 3. The 3's cancel, and it simplifies to square root of 3. Last, we're asked to find the sine of 30 degrees. Here, it's a little bit more challenging to relate the information that we're given. But if you recall, the tangent equals sine over cosine. And we're also given what the cosine is, so maybe something might cancel out. Let's try it. So if we look at the cosine of 30 degrees times the tangent of 30 degrees, and we recognize that the tangent of 30 degrees is equal to the sine of 30 degrees over the cosine of 30 degrees, then we can see that cosine of 30 degrees and cosine of 30 degrees cancels, and we get sine of 30 degrees, which is what we're trying to find. Since we've shown that the cosine of 30 degrees times the tangent of 30 degrees equals the sine of 30 degrees, we can now just substitute in the numbers that were given in the problem. The cosine of 30 degrees equals the square root of 3 over 2. And the tangent of 30 degrees equals the square root of 3 over 3. If we multiply these numbers, square root of 3 times square root of 3 is 3, over 2 times 3 is 6, and we get 1/2.